This is a mold. This is a mold that I'm making for an electric longboard project that I'm working on. Now, the board itself is already done. This is a mold for the electronics enclosure. So this has got to hold all the guts of the thing, right? And so the project itself, well, I'll keep you up to date on that. It's pretty cool. So here you see the electronics. The batteries are going to be a little bit different, but the box itself, as you can see from this mold, it's going to be long. It's going to span just straight the length of the whole board, so I can pack it full of LiPo batteries. So that's kind of the big diff. I'm not going to use 18650 batteries. I'm going to use the LiPo, same kind of LiPos that we use for our FPV drones. So we should get lots of current out of this. So anyways, what I want to do here is I want to take an opportunity to show you another video on Composite, since it's been a really long time. So I want to show you how we do the vacuum bag for the actual this box itself, and then the rest of it, after it's all cut and trimmed out and added to the board, we'll do that in another video down the road. Now, incidentally, last thing, a couple last things here in this intro. This here, what you're looking at, is a really old mill of mine. I built this, I guess it's not really old, but I mean, it was about 6-7 years ago, this version of this, and it's still hanging in. It is rickety as all hell, but it works great for wood and plastic and cutting out snowboard parts and things, right? The other thing I want to mention is that, you know, the video, I didn't happen to, it's kind of all cobbled together from some snippets I had, and I didn't have my lapel mic on, so you're going to hear a bit more, you know, shop noise and all of that. So here's the mold done. So here's a vacuum bag. This is stretch lawn, and it's the stretch lawn. It's like 500 or something like that. It's like 5-to-1 stretch or some deal like that, right? So it's got a little bit more stretch, a bit more stretch than the typical. But I use this on top of the regular bag. Nothing real special there, but I just wanted to make sure that between the pleats and this flexibility, I wanted to be able to get enough. Well, lack of bridging. I wanted to get it to press down into the cavity the best as possible. Composite-y stuff. Bridging is in any kind of a case. Well, here, let's look at this right here. So right in here, you can see a little bit, you know, how it's kind of sucking down in there, but it ultimately, it just can't get quite in that corner, and that's bridging. And if you've got a really hard bag, when you go to suck something down in that, you're going to get more of a curvature, or not, I mean, more of a straight out here. And then that part of the bag is not going to be sucking in to the product. And so that's a bummer. That's going to be a problem in a case like this. You know, if we're talking about outside the thing here, because you can kind of see it's actually kind of sucking in pretty good. But anyways, this wouldn't matter so much. But in here, we need the pressure down into the mold. And this, being a concave mold, a lot of times if I want really good conformity, I'll make the mold basically backwards. People look at a mold like this, like a cavity, and they go, oh yeah, that's a mold, and they don't think of something shaped, you know, positively as a mold, but you bet. And with composites, it drapes over it, and the bag will pull down on it, and it works better. It's harder to get it into these contours, but the reason for this is the other side, when I pull this out, is going to be a cosmetic, hopefully, you know, a relatively decent cosmetic surface, so I want that against the, you know, the tool side down there, and so I have to deal with this. So hopefully it's sucking in well. If you can't get it to suck in good, then you got to put something in here like a call plate, or, you know, a whole nother piece that looks just like this, and then you end up with still a pile of problems, because even though it seems like it would be good, it doesn't press in quite right, and it gets kind of trapped because of the multiple layers of buildup. Kind of more than I want to mention, but basically what I'm saying is this trapezoid that you might have in here, because maybe your stack up is thicker than you thought it would be, it gets wedged and it won't suck down actually all the way, and so then you're not getting as much pressure down there. So problems, you know, composite world problems. And on top of here you can see the holes, so I've got a perforated film on top of that. So the perforated film allows the resin to go through into the breather cloth here and soak up. That's why you're seeing little dots everywhere. We do that because this breather cloth right here, the fuzzy stuff, we're using that to suck up all the resin, and so we need some kind of a material that under vacuum, as it gets compressed down, it won't compress all the way, and you'll still have like voids inside of there, but those aren't full of air, they're full of vacuum, if you want to think of it that way, and it wants to pull the resin into that. If we let that be right on top of the product, well, that's going to be permanently bonded to our box here, so that's no good. So you use a real thin, it's really thin, it's a real thin separator film with a bunch of little holes in it, allows the resin to come, squeeze on through there into the perforator. We'll be able to peel this right off, and then we'll have the product. Okay? Incidentally, that is not peel ply, that's a different material in itself, which I did not use in this case. Now, looking right here, our vacuum is great. I think that this gauge is probably a little bit wrong, but it's great. We've got this pump right here, this little gurgle pump. They smoke a lot. See if you can see this. Yeah, see that? Blah, 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 blah. So that's, the whole shop kind of smells like crayons. They say online that that's just the nature of what they do, and it's okay to run them all night long, and so I've done that lots and lots, and it seems fine. Just keep an eye, on your gauge right there and make sure you don't run out of oil. But these ones, they're about $650 last time I bought those several years ago. But they work really well. The diaphragm pumps work pretty good too, but this one gets a bit more suck, so I like that. Now, anyway, it's done. It's been here for 24 hours, so I'm going to pull this off. No heat, so this is all just ambient cure. This is a lot of the way we do things around here, the snowboards, the longboards. If we need some heat, if it's cold in the shop, we'll do that too. Right. Then I wanted to also point out down here, this is pleating. So this is what we'd call, a pleat in the industry, as you'd say. So what you got to do is you've got to, when you double back, this is double back tape. It's just really thick, gooey double back tape. It's kind of like putty, right? And it's sealant tape, they call it, but we just say tacky tape or whatever. But anyways, you got to develop a really good technique on how to make these things, because the bag sticks up to here, wraps around here, down here and over there, and even though that's kind of messed up, there isn't any leaks in this, right? And that's the hard part. Put it this way, if I'm looking at this pressure right here, if I were to take a pin, we have done this for testing's sake before, and poked a hole in it, that would drop by a couple inches of mercury, a couple numbers, right? If I've poked 3 holes into this, 3 pinholes, this drops down to like 18. And if you get lower than, let's say, 22, for aerospace things, that's the bare minimum. I'd say that's still not even good enough. Then you've got kind of a problem. So if I have a leak in a pleat, if I've got a wrinkle in here somewhere, if I got some little kind of a thing here that allows air through, that's, really large, in contrast to like a pinhole, and you're not going to get the vacuum that you want. So that's why this process here becomes really super tedious. Now, the reason again for this is we need to make extra material to go into here so that it will wrap to this. If we just locked it down, if we just sealed this all down around here like so, tight, this would bridge right across here, and we'd get no pressure down on this. So you've got to make pleats here. Essentially the idea is you put it in all corners, okay? Oh yeah, by the way, go check out my other videos. There's the heavy lift. So today is first flight, so I figured I should show you this because I'm working on this on the side here. So if you watch that video and you wonder what's gurgling, that's that. Alright, so I'm going to cut this open, but I forgot my camera tripod mount, so I got to kind of hold this and work around here. So normally I just sort of rip it open, but I'm just going to kind of try to cut this while I hold this and deal with all the other crap I'm doing here to record all this. So typically, I don't know, do whatever you want here, but you disconnect this. So here, quick connect. If you're doing this, buy these things. They're a little bit more expensive, but you can get this and this. They're about $35. Get them, sorry, not focused, from AirTech is a place that sells these quite commonly, but just look around. The quick connect makes your life so much easier than doing things like taking a hose and just stuffing it in the bag. with some fuzz around it so that it doesn't pinch off. The other thing is they have these little plastic suction cups that you can hook onto the end here, and you just stick it on the surface, and that works pretty okay. I just say that this is better because those little plastic suction cups, you got to run them with tacky tape, and it's just another hassle. Not too bad though, not too bad. Okay, so get this over here and turn off the pump. Okay, so pump is off, and then this. I always tell people whenever you take this off, first thing you do is rip this open and get this back onto here, because I always get worried that people are going to cut this whole thing open in a frenzy to see what's inside here, and they're going to wrap everything up like you do and throw it in the garbage and lose your foot. This right here, more expenses. These little feet right here, they're about $35 also. And then you get all these other little brass fittings here, so maybe like $5, $10, $5, I already said like $30 or so for the set of that. The gauge I think was about $70 or $80, really handy. I like this here. This is kind of a setup that I just came up with. A lot of people do stuff like this, but you have a valve here that you could release pressure if you needed to. I've very rarely needed to do this. Like if I needed to suck something down and I didn't want max pressure. Okay, anyways, more money to spend. These hoses right here, this is not quite the heat rated one. It does work out okay, but you're going to spend another $100 or so on just a hose like this. One weird little hack I did is if you look over there, see the little oven? So I had a little old oven, and what I did is in the back where the vent is, I knocked that vent out, and the vent, this will perfectly fit through that little vent. And so now if you've got something that you want to put in an oven, an old crapitated oven, you can turn it into a pretty decent composite oven, as long as you get yourself a hose and all your material here is heat rated for what you're going to do. Now with a liquid resin, you really only need to heat it up to like 120, 150 will get this thing done, 160 will get it done in about an hour, but you don't necessarily always want that because you want to have time spent on this. I like to have time with the liquid resin to get it to pull the resin out nicely. If you just go bam, snap, and freeze it, all this, cured instantly, all that resin that's inside there just solidifies and it never has a chance to pull on out. So give it a chance to do that under, cool-ish temperatures, like maybe say 60 degrees. I've noticed when we're whipping up resin, it's not exactly a phase change, you could call it that, but it gets really thick, let's say under 60 degrees, but you warm it up a little bit past that and it gets a lot more fluid, and then that's going to pull out a lot easier. The hotter you go with that though, the faster it's going to cure. So there's your fine line that you got to balance. And incidentally, this is epoxy resin. Around here, if you ever see me doing any more composite videos, I very, very rarely, like never, do I use polyester resin. It's always epoxy. It's quite a bit more expensive, but it is also substantially better all across the board. Okay, so let's cut into this thing. Oh, jeepers. This is going to be stupid with one hand. I also don't like on my tables here to cut too much with a knife on there because it scratches the table, which in itself is not a huge deal, but when you're laying out composite materials, kind of snags on it sometimes. Or we'll just do it like this. That should probably be okay. There we go. So you see, the vacuum bag material, it doesn't, vacuum bag material doesn't stick to the resin either, which is really nice. And then here's the mold. So this is MDF, kind of a thing I do a lot for quick, fast molds. Now this here is the breather cloth. So you can see it's just fuzzy. If you went to a fabric store, it's basically batting. It might not even be basically, it might be exactly the same thing, but it does have a heat rating on it, so I don't know if there's anything different that they do to it. But so at any rate, and it comes in different kind of, thicknesses, I guess you'd say. So some of it is thicker, which means that it's going to have more voids in it, so you can suck more in it. Or you can use the thin stuff, and you could double it up, triple it, quadruple, whatever you want to do. But the more, so this is critical, the more that you feel that you need to suck out of it, you add more breather. But when you add more breather, it dramatically reduces the amount of pressure that you're going to put on the actual product from this outside here with the vacuum bag. Think of it like this. If I put, something down here and I put a mattress over the top and I try to press on top of it, I'm not going to get so much pressure on that, you see? So what you need to do is, one, make sure that you don't do a layup with too much resin. And so then you could use it thin like this. And then if you do use extra resin, which is actually not a bad thing to do, if you're not trying to conserve as much as possible, you make sure that you get it in there, you don't have any voids, so that's a nice thing. But before you do the layup, like on this one here, I got a bunch of paper towels and laid it down here, and I, soak it all up and then get rid of the paper towel, do it again, get as much resin out of it beforehand before you do the bag, if it doesn't disturb your part, right? Okay, so then this should come off of here, and then this, I had to cut it up and pleat it and do some stuff to it, but this is the perforated film, if you can see that there, right? See the holes in it? So this should come away nicely, right? So there's our soaked up breather cloth. And looking at the back side here, it looks like it did suck into it pretty good. So that's cool. Get rid of that. Then the perforated film should come off right away. And don't expect this to be, major ooh and ah, because this is not the tool side. Also, the other side, don't expect it to be super wonderful because it's kind of a prototype mold. It's not steel or aluminum. If you want a really nice mold, you're going to make it out of metal or something like this that you could buff to a shine. If you want it to look like glass, you use something that's like glass, right? Now, the other option, of course, that you have that, it's still kind of gummy. That's not good. That's not good. Feels okay down here. It might just be the wax intermingled with it. That happens a lot out here. I used a paste wax and I did a spray wax, and the two together quite frequently kind of goop up each other, and so I bet that's what that is, because it feels kind of okay down in here. It'll probably be kind of gummy. I'll make a decision as I go to yank this out of here what I want to do. What the hell was I talking about? Oh, yeah. So when you pull this thing out of here, if the surface isn't quite so good, but the process is easier and substantially cheaper than the maybe other way, whatever it is that you want to do, then you can always say, well, that's fine. I'll do a light sand on it, and then maybe I'll do a clear coat on it. But a clear coat, if you don't use like a really nice automotive polyurethane, like a two-part mix, if you just use the rattle can stuff, it really is not as nice. The epoxy resin is, it feels, almost like really, really hard plastic or like a glass almost, whereas the polyurethane always has this little bit of a kind of a gumminess to it, Here's another critical thing. If you do sand it because it's bumpy a little bit and you want to sand it down, beware. You might not even want to do that, because if you've got this weave right here and I go to sand this a little bit, what will happen is as you're sanding it, the dust will get into all the little weave cavities here. And then after you've sanded this thing down to feel really good, you see all these little white dots everywhere, which is your sanded resin inside those little holes. And you wash it and you wash it. You wash it with some alcohol or water maybe or something like that. And sometimes it's just like impossible to get that out of there. So you might not even want to touch it with sandpaper, because it could screw up, after all your work here, you end up with a product with freaking dots all over it, right? No good. So I need to get maybe some wedges here to pull this out. It does feel gummy, but it does feel like it's, like I say, more solid here. Hold on. I'm going to have to pause this for a sec. Okay, well, I think this might work. So I got my spatulas, not my wedges, but I'm running them around here, trying to break all the sides free. Sorry. Okay, we'll let that sit there. Take another one and kind of stick it here. So yeah, so I don't have a whole bunch of wedges. I usually just use spatulas. Oh boy. Oh yeah, there we go. Excellent. Okay, that's honestly that was good, but that's pretty typical. It's like nothing, 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 pop, and the whole thing comes out. So let's see what we got. Again, like I said, I'm not hoping for stellar. Oh yeah, look at that. So that is okay. This is probably mostly just waxed up resin. I don't know. We'll see if we can wipe that off of here. But this, no, that's kind of, yeah, that's sort of waxed up resin, I think. Anyways, so what I will do is sand this off. I will sand it down. I'm going to give it another day or two to kind of really extra cure and off gas and such. These room cure things, I mean, you can pull them out after like a day if, say, it's like somewhere, you know, around 70 degrees. You know, 24 hours is reasonable to pull it out of there. But really, it's not going to be completely done cured for possibly even a couple weeks. And if you're going to do something maybe even more professionally, you might get yourself some kind of a like a durometer tester or a barcoal tester. You know, look those things up. Some way that you could test this to see, you know, before I start working it, is it, you know, hardened up to the spec, right? Like if I go to cut this out on the bandsaw, I don't want it to be gummy. Carbon's got a really bad shear strength, but that means it cuts really good. So if I cut through it, it just goes psh, and it cuts nice and clean. But if it's kind of gummy, then I start getting delam on the edges. The mold, by the way, this step that was left here was not, that was on purpose, so it will create this little lip, and that gives me a guideline right there, because I kind of suspected that I was not going to cut this out on the CNC, because I could just hand do this, sand it pretty good, round the edges by hand, and just decide where I'm going to drill the holes to mount it to the board. All right, seems okay, definitely okay for a prototype, and, you know, of course, go from there. Anyways, that's all I wanted to show you. This is the demolding of the carbon fiber, if you didn't realize that already, electronic box for the electric longboard project that I'm working on. Piles of batteries.